All right, today we're diving into a really cool new AI framework called ReMiT, and it's all built around a simple but kind of mind-bending idea. What if an AI could actually teach itself to be smarter? This is a technique that could totally change how we train large language models, so let's get right into it.
Just picture this for a second. What if a fully trained, expert AI, the smartest version of itself, could go back in time and give its younger, less developed self some critical advice? That's the wild question at the very heart of the research we're breaking down today.
Now, to really get why that question is such a big deal, we have to look at how AI training usually works. And honestly, for the most part, it's a one-way street.
So, the way it usually works is you start with pre-training. This is where the model just gulps down massive amounts of data from the internet to learn the basics of language. Then you move to mid-training, where it refines its skills on much higher quality stuff. And finally, you get to post-training, where you use fancy techniques to really sharpen its reasoning. It's a linear path, from a generalist to a specialist. And right there, that's the problem. That final, super-tuned model has learned so much about logic, about reasoning, about how to get things right. But in the standard process, all of that incredible, hard-won knowledge is just stuck. It's at the end of the line. There's no way for it to loop back and improve the model's core foundation. It is a massive missed opportunity. The researchers behind ReMiT knew that if they wanted to break that one-way street and create a feedback loop, they had to find the absolute perfect moment to jump in, and they found it. And that perfect moment, it turns out to be that mid-training phase. You see, this is a really critical stage where the model is already starting to learn advanced skills from high-quality data. Think scientific papers and computer code. The researchers realized this was the golden window of opportunity to inject some wisdom from a future, much smarter version of the model.
But, okay, how do you actually transfer that wisdom? Well, the key insight here is that the advanced AI smarts aren't just spread out evenly. Nope, it's concentrated in what the paper calls pivotal tokens. Think about it like a math proof. Most of it is just standard setup, right? But the real magic, the breakthrough, happens in a few key steps. Those are the pivotal tokens. And here, you can literally see what we're talking about. Those red areas show exactly where the advanced model is way more confident about the right next word than the base model is. We're talking about those absolutely crucial words like therefore or adding or the symbol that flags the final answer. The smarter model's edge is laser-focused right on these key decision points.
So, armed with this insight, the researchers created ReMiT. And honestly, the best way to think about it is like an AI flywheel, a system that kicks off a continuous, powerful cycle of self-improvement. And this diagram just lays it all out perfectly. Instead of that dead-end, one-way street we saw before, ReMiT creates a loop. The knowledge from the advanced model gets fed back to guide the training of the base model. That makes the base model better, which then becomes a stronger foundation for the next round. So here's how that cycle actually works. First, you start with a highly tuned mentor model. Then, this mentor guides the student model during its mid-training. It's basically whispering in its ear, hey, pay extra attention to these specific words. This guidance creates a much stronger base model. And what happens when you have a stronger base? You can create an even better mentor for the next round, and you can just feel that flywheel starting to spin. You know, the researchers themselves don't mince words. They call this a paradigm shift, moving from that standard one-way pipeline to a bidirectional, self-reinforcing flywheel. And when you see the results they got, you really start to understand the excitement.
Okay, so it's a really clever idea in theory, but does the flywheel actually spin faster in practice? Let's take a look at the numbers. Across 10 key benchmarks for things like math, coding, and reasoning, ReMiT delivered an average improvement of 5.2%. Now, that might not sound like a lot, but in the world of AI, that is a huge leap in capability right out of the gate. And get this, it's not just better, it's way, way faster. The ReMiT model hit the same performance level as the standard model a whopping 6 times faster. I mean, that is a massive jump in training efficiency, which translates to incredible savings in time and, of course, a ton of money on compute. But here's the really crucial part. These aren't just some temporary gains that fade away later on. No, the improvements made to the base model are durable. They stick around, creating a stronger foundation that benefits the final, fully tuned model at the very end of the process. Just look at this chart. It tells the whole story. The ReMiT model, there on the right, starts with a huge advantage during mid-training, and it holds on to that lead all the way through to the end.
The flywheel gives it a head start, and it simply never looks back. Okay, now there's a really important distinction we need to make here. You might be thinking, hey, this sounds a lot like a technique called knowledge distillation, where a small student model just copies a bigger teacher model. But ReMiT is fundamentally different. It's all about guidance, not just blind mimicry. Here's the difference in a nutshell. Knowledge distillation, or KD, basically tells the student model, copy everything I do. Exactly. Don't deviate. It forces the student to mimic the teacher's entire output. ReMiT, on the other hand, is much more of a gentle guide. It says, you're on the right track, but just pay a little extra attention to these critical concepts I flagged for you. It's a much lighter, more targeted touch.
And this guidance approach, well, it's just plain smarter. By not forcing the student to copy the mentor perfectly, ReMiT avoids overfitting to the mentor's specific habits and quirks. This means the base model keeps its flexibility, its potential for future growth, and that leads to much better, more robust performance in the long run.
So let's zoom out for a second. What does a self-reinforcing training loop like this actually mean for the future of AI?
The biggest takeaway here is that this isn't just a one-time trick to get a quick boost. ReMiT establishes a real mechanism for ongoing, iterative improvement. It's a pathway for models to get progressively smarter by learning from their own, more advanced future selves. And the paper really drives this home. It highlights this incredible cascading effect. A better base model makes a better mentor, which in turn makes the base even better, confirming that this thing is built for continuous self-improvement. That flywheel just keeps on spinning, and it gets faster with every single rotation.
And that leaves us with a really fascinating thought to chew on. For years, we have been the ones teaching AI. But frameworks like ReMiT, they feel like a turning point, a moment where AI really starts to teach itself in a fundamental way. So if these models can now iteratively improve their own foundations, what in the world are they going to be able to do tomorrow?